Hello everyone, welcome back. I'm excited to announce that I'm officially working on a game. Not just me, I'm the programmer, but as a group we're Dippo Studios. The game's called Project Oxycoral. Basically it's an underwater farming sim, kinda like if you combined Subnautica with Slime Rancher and Stardew Valley. So this game takes place entirely underwater, and there are a lot of different approaches to making water in video games. You need to ask a lot of questions about what the water has to be capable of, such as, how close can the player get to the water? Can the player go under the water? How much of the water can you see? What kind of body of water is it? Can the player swim? If the player can swim, how does that work? Does the water need to have life-accurate physics simulation and one-to-one interactions with light, including refraction, reflection, scattering, caustics, and other effects such as spray, foam, bubbles, and ripples? And most importantly, how much of this can we fake? So for this video, I'm going to be going through our current implementation of an underwater environment for Project Oxycoral, starting literally from the ground up with the terrain. Okay, so in 3D games, there's two main ways that terrain is created. The simpler way is using a height map, which is exactly what it sounds like. It's just a map of how high or low the terrain is at any given point on its surface. This approach is good for creating exclusively the surface of a landscape, and the downside of it is that you can't use it to make things like overhangs, caves, or really anything that isn't just the hills and valleys of a surface. For the other stuff, it's best to use a voxel-based solution. Voxel is just a 3D pixel, which is just a cube like Minecraft. Although Minecraft's terrain is obviously procedurally generated and it's much more complicated than just saying it's voxel-based. Oxycoral, as many games do, uses a mix of both height map and voxel-based terrain to get the desired effect. A tool for height map terrain is built into engines like Unity and Unreal, but we're using Godot for a whole bunch of reasons which I'm not going to talk about today, but maybe in the future I will. Godot's design philosophy of being lightweight and free of bloat means that it doesn't have a height map terrain editor built into it. Fortunately, there's an add-on called Terrain 3D that solves this problem for us. Unfortunately, voxel terrain tools are a lot less common. From what I've found, any tools for Unity or Unreal cost money, and the most popular one for Godot isn't very easy to manually edit. However, I recently discovered this add-on for Godot, which is admittedly a little primitive, but it is exactly what we're looking for, and it's only in version 0.2, so hopefully the developer will keep updating it with new features and stability. As a smaller note, foliage is also pretty important for terrain. I drew up a little thing of grass really quick to show as an example, but we definitely need a lot more than just this. So that's what we're using to create terrain. A height map as a base, and then voxel meshes for details. Okay, imagine the surface of the water as a giant square. If we turn this square into a bunch of smaller squares, that's called subdividing it. Now we have what looks like a bunch of points on a grid. I can tell these points to move up and down to make it look like there's waves. Then I can go online and search for free online water normal map, slap that bad boy on it, and now it looks like water, kinda, from certain angles. Okay, admittedly this part is still a work in progress, but I don't consider it very important because we don't have any plans to put anything above the water, so we honestly might even just make it so you can't even leave the water. I don't know, it's fine for now. One of the most important things to know about game development is that everything's fake, right? It's all just a bunch of math that puts colors on your computer screen and tricks your brain into seeing exactly what the developer wants. Like, it's very difficult to accurately recreate almost any complex natural phenomenon within a computer. However, you may remember the question I asked earlier in the video, and most importantly, how much of this can we fake? So it's time to answer that question. But first, we need to answer the questions of what we want the water to be able to do. So obviously the whole game is spent underwater, so let's look at what underwater looks like. Okay, so it's basically just blue fog that gets darker as we get deeper, some bubbles, and this weird light effect thing that I'll get back to in a minute. Starting with the fog, that's simple. Obviously, it isn't actually that simple. There's a lot of settings we need to tweak, and technically we're using 2 or 3 different types of fog depending on how you want to categorize it. There's exponential fog, which gets denser as the Y level goes down, and there's the fancy volumetric fog, which goes over that, and is also used as the world borders. What's the difference between volumetric fog and exponential fog? That's a great question. I have no idea, because I'm not a graphics programmer. Any code that has to do with rendering anything is absolute witchcraft to me, so I have no idea. Let's move on to the bubbles. These are as simple as grabbing a particle texture pack online, getting the one that looks like a bubble, and setting up a particle emitter. Having bubbles come out of nowhere doesn't really make sense, so for now I've attached them to the currently very primitive fish, so they're blubbing now, I guess. Now let's go back to that weird light effect I brought up earlier. these are called water caustics, and I think they look really cool, so of course I'd want to put them in the game. This is also where the whole everything is fake thing really comes into play. As mentioned about 15 seconds ago, I'm not a graphics programmer. I have no idea how to use ray tracing to accurately simulate something like this, but I can sure as hell make something that kind of looks close enough. So there's this thing called whirly noise, and it looks like this. Let's say that in this image, white represents the number 1, black represents 0, and all the grays in between represent all the numbers between 0 and 1. Now if we take 2 of these images and move them over each other, multiplying the numbers, we'll see that the dark parts get darker, and it leaves us with just the brightest parts. And it gives us this wibbly wobbly pattern, which is pretty much exactly what we're looking for. Now all we have to do is separate the RGB channels to make it look a little bit nicer, because chromatic aberration is sick as hell, and apply it on top of our terrain. Which definitely didn't take me multiple months to figure out, because Terrain 3D has its own terrain material, Godot material, which makes sense, but it also means there's no second pass on top of the material you already have, so I desperately made 2 different posts on the Godot forum, which I ended up solving on my own the day after. There's also the problem that obviously the effect would have to go away when it's under a shadow, which wasn't happening. Data out of the shader's light function, so I couldn't tell it when it was and wasn't under shadow, so I ended up needing to make a duplicate of the terrain mesh to put the material on top of that, so that I could use the albedo channel instead of the emission channel, which let the effect go away in shadow. Huge thanks to this tutorial. I would not have been able to do this part without it. Everything I mentioned above I had to figure out all on my own, but the original shader code pretty much came entirely from that video. So that's it. Links to all the references and everything I mentioned are in the description, and like and subscribe if you want to stay updated on the game.